So let's fix first a few issues we have with some deadlocking, because it really gets a little bit annoying. So if we press the right bumper, it works fine. If we press the left bumper, well, everything now starts to break. That is because we are clicking to attack, but we are actually, we don't have an actual state that we are going to. So it just waits forever for the animation to play, which it never does. Okay, so let's go on to our input manager first. Let's see, where are we changing those? Okay, then basically it's the handle tagging. Okay, then play target item action. You're playing the animation. This will now go and check for the animation. Thing is that the change state, which we are doing a check for no action found, although I think the debug log never showed. Yeah, the debug log actually never shows. And yeah, because the item container, we will always have an item container. So the problem is, it's not the item container that it doesn't exist. It does exist, and it always is going to exist, but it's basically it's not going to have either an item action, or it's not going to have basically it's not going to play the animation, so the animation will just go out and it will basically won't play. So we need to do something about that, although that won't be a problem when when you actually have proper items and stuff like that. That won't really be an issue. You could still just use it just fine. So let's clean this up a little bit just so that we know what we're doing. As we said, item action container, it's never going to be an instance that it's going to be null, since we populate and just replace values onto them. And let's see, let's go and check. For example, we can say item action let's say if that's going to be null first. So the default item actions, as we can see, okay, so I think that's going to be missing. Let's hit play, although this is just for the default items, so it wouldn't make much of a difference. But let's see, as you can see, it does stay false, so that means we even have an item action. So, well, that means we don't have an animation at this point. Okay, so this does execute the action, which we only have one action. That means we have the attack action. And it's going to play the animation we wanted. Okay, the problem is that we actually don't have an animation because the item doesn't really have an attack button for there. So we need to make sure we have at least something there. So, which kind of makes it interesting, because this will have played or otherwise, no, it's here. So here's what we're going to do. Let's say string the target animation, and it's just going to start as, let's say, punch 1. Okay, we don't want the return. We can say if now the actual index for the animation is lower than the length of the animations we have, then replace it with this. Okay, Awesome. So yeah, so basically it's just going to play a default animation so that we know that it's not going to deadlock, but we do need to make sure we have the correct IDs for this, which in this case is going to be this one. Okay, so yeah, it might not feel that productive, but it really helps knowing how to debug stuff like this, because as you saw, I went through 3 different scripts, through 3 different layers for a code, and found what can be changed to just make it so that we do not have those deadlocks. And that didn't actually work, as you can see. I'm still on a deadlock. Awesome. So here's what I'm going to do next. Problem is why we are on a deadlock. So let's see if we are even coming in here, which I think we're going to. Let's say target anim. One item. That's interesting. Yeah, so target anim is actually wrong, and yeah, this is actually wrong because actually no. Let's put a breakpoint here, and you will see. I think I know what it is, and I think I know what's going to happen. How it's going to happen actually. Okay, so let's hit play. And I'm going to press to attack. So here's a breakpoint. Okay, so far so good. And let's go in. And as you can see, we're going inside, even though we don't want to really go inside. The reason why we're going inside is that our item container does have values, but they don't have any names on them. So that means our item container has a lot more attacks, or well, it has values which don't have IDs, so that's actually a problem. So that means it's trying to play an animation that is not properly set. Basically, it's trying to play an empty animation, which of course it can happen, so we are stuck on an endless loop there. So I think we need to check why we have that many. Yeah, why there are so many empty attacks, especially when we only have these 3 attacks at least for here. And let's check the default item actions, and yeah, that's it. The size of them is 0. Now, for the default items, basically the attack names should just stay 0. Okay, and now this should probably fix it. And yeah, it did. Okay, but that's not the best case scenario for this, because you might still want to have a check so that, you know, this can easily be missed. So I'm going to put a debug log for here saying if string is null or empty, target anim, do a debug.log warning for this saying target anim, target animation is null or empty, hardcore assigning default value. Okay, and then just say target animation punch, punch 1. and it will continue to the rest. So we have all that. Yeah, so basically this is a failsafe for if this, because you can still have values on them, and I guess we could just check the string if it's null or empty as well. And assign it only if it does have a value. Otherwise, it's just going to play this one, which is the default one, which is going to circle back. So everything should be fine. So we have two failsafe at this point. I guess we don't even need this one, but let's keep it. Let's not delete it. Let's just copy it. Also, the anim index should be higher than -1. Okay, just in case we want to make it so that there's no index. Although, yeah, I guess if we had it at -1, then this will throw an error. But anyway, let's just keep it as a failsafe, just to be sure. Okay, so that's the first bug we had, which we can still, yeah, okay. We have our normal combos, awesome. Okay. Now, let's work with the lock-on we have. First of all, let's go on to our input. And let's see what do we have here. This is for handle the attacking. On clear look override, let's see. Okay, or assign look override. Okay, so we need to do something that it will assign you targets for this. So inside our input manager, we can either do this here or we can run it on the state manager, I guess. I'm actually going to run it on the character state manager. I'm going to write the logic. And I'm going to say public transform and find lockable target. Let's just say return null for now, and we need to run the logic for this. So let's go and open up a utilities class. Let's say R2. And this, we're just going to keep our interfaces here. We don't really care for anything else. Public interface I lockable. Get target or get lock on target. Oops. Yeah, we don't have a body. And actually, I just want to return the transform. That's what we need. Get lock on target, and we want this to be. No, let's keep it like this. We can expand on this further later, but right now we don't really care. So this will be the character state manager now can derive from I lockable, which we will have now to implement an interface. So get lock on target. Maybe we need to assign, let's say return null for this. Maybe we need to also assign who actually requests the, yeah, let's do it like this. Let's say transform from. And this now became a method, but we have to assign, we have to change it on the interface as well to be using the method from the interface. Okay, first of all, we need to check if from equals this dot transform, then simply return null. Else you can just return the mTransform for this. Okay, so this will basically get you, at least for right now, we don't really need anything else. We can just use this. So basically the idea is to just look for lockable targets. Later on we can put priority so you don't lock on a barrel or whatever. So find lockable target. We're just going to go with the easiest way I can think of. Let's do, okay, let's say iLockable. Actually, no. We should do physics.spherecast or overlap sphere actually. Okay, the position will be your own position. And radius, this can be a variable, let's just say 20 for here, we don't care. This will return us every collider that exists in our case. Let's say colliders. Now, we can make it a little bit easier if we, or well faster, in this case, for this method, because this is going to return you all colliders that exist in the scene. We just want, if we assign, for example, some of this, for example, a controller or a layer for this, let's assign the, let's add a capsule collider on this guy. Let's add a rigid body as well, but we have to make it kinematic, otherwise he's going to fall through the ground. Let's assign the damage collider as 9. So back to the character state manager. You can pass the layer mask, in this case it's going to be 9. Then for each collider or C in colliders, we need to find the iLockable, if it has an iLockable. Get component in children, iLockable, and if it's not null, okay, then you have your transforms. But this doesn't really make, we don't have anything that says, it's a valid target for us. So let's start filtering things out. First of all, you need to know, you need to check if it's forward of your, if it's basically in front of you, or if it's not in front of you. You can do stuff like this, but I think we did this on a previous refactor and it was more of a problem. So let's maybe not check that. So let's just go by distance, and I'm going to say list find me all my iLockables. Okay, and then lockables list, add iLock. Here we have now our lockables, and now we need to find them by distance. Vector 3.distance. Oops. So now let's do, and then this will be minimum distance. Okay, transform target, let's set it as null, then for lockables list dot length or dot count, then float distance or temporary distance, vector3 dot distance lockables list I dot get lock on target from your aim transform, just so that we don't get ourselves, because we are going to get ourselves there. And vector3, yeah, aim transform dot position, and if temporary distance is lower than the minimum distance, then the minimum distance now is going to be your temporary distance, and then your target is going to be your lockables list I get lock on target and transform, and this needs to be get lock on target and transform dot position. So some optimization, because you might be running an entire method over here. Okay, we can just set it like this. So this will be target dot position. Oops, oops, and oops. Oh, come on. Oh. And yeah, we don't have to run this before again. And over here, just return your target, and there you have your lockable target. Okay, which means find lockable target. On to your input manager now. Instead of clicking F and hard coding it, you can say s.target equals s.find lockable target. If s.target is not equals null, then assign look override. Okay, and there you have your lockable targets. So, okay, there goes that. Let's test this. Okay, so the F doesn't actually do anything, but it might be because of this. We have downwards collider. This is the 9. Okay. Okay, so let's see. Yeah, it doesn't do anything because it doesn't have anything. Let's see. Do we have an enemy? Yeah. We actually need state managers for this, and we only have a character state manager, which we can't use just by itself because in an abstract class we need an enemy state manager or an iLockable hook that can work as well. So instead of creating the enemy state manager, let's do let's do a lockable hook, just so that we do not get ourselves confused with the enemies at this point in time. We're going to make them later. So let's delete this one. Okay. We just need a mono behavior, and we're going to assign the iLockable. Okay, we're going to implement that and simply return me the transfer for now. As you've seen, the character state manager, the interface, the implementation for the interface is a little bit, well, it has 2 more lines of code, but it's going to come into play a little bit later. For now, it's okay. Awesome. And yeah, we do need to add it on this guy as well. Save it. Let's hit play. We still can't lock on, and I think it might be the layer that does it. Although yeah, okay, so here's what we're going to do. We're going to remove the layer. Now we're going to be getting our own shelf, I believe, here. And actually we can test this. Let's put a breakpoint and attach it to Unity. Okay, let's go closer and let's press F. So let's see what we have here. Our colliders now, we did find 4 colliders. Okay, that's, as you can see, we have our player controller, we have our far east set, and we have the plane and the cube and everything that can be in there. Then the next thing that's going to happen, we're going to find the component for the iLockable, and for 4 times in this case. As you can see, for the far east set we are inside, and here's what's going to happen next. On the iLockable list, the first one is going to be the far east set, the second one is going to be the player controller. The player controller is probably going to give us, not probably, I'm like 99.9% sure that it's going to give us an error. Okay, and you'll see why. Because the get lock on target, the method that we are implementing on the character state manager, which is this, checks if the base transform, in this case this transform, is the same as this script. So of course it's the same, it's going to return null. Because we are not doing anything to catch cases that this is going to be null. Okay, then that means we're going to have, yeah, basically that means we're going to get a null reference error. Okay, and true enough, you will see that there it is, we have an error. So here's what we can change to make this a little bit more safe, or actually even better, we can just do it like this, and instead of saving the iLockables, we can just save the transforms themselves. Okay, and let's see, get lock on transform from the iLock. Okay, can delete this. Lockables list i.position, and then lockables list. And if t is not null, just add it there. Okay, so this basically will only give you transforms instead of the iLockables, and it should be fine. It should be filter out now the cases that are our own self. So I'm going to put a breakpoint here, and I'm going to check what values we're going to get now for this. Let's go. Okay, colliders. So colliders, yeah. Where? What? So yeah, this is the ignore layer. So it's basically going to ignore everything else, which means we just need to do layer mask. We need to do the opposite of this. So it's only going to cast it as on. It's going to ignore all other layers, but the 9 layer. Well, at least that's what I thought it's going to do. So that's it to Unity. Or I think it doesn't need to, yeah. Let's do it like this. I think we were inverting them when we only want them to cast on the 9 layer. So bit shifting it, that will do it, I guess. Yep. Okay, so there it is. We now have there it is. We now have the positions we need. Well, we now have the lockable targets or the lockable logic that we want. We can find dynamically target objects like this. Now let's test we have that. We have the forest set. Let's duplicate it and let's check the distance. So as you can see, I can lock onto him, but if I press F again, I'm out of the lock-on. Let's go back. And now we are on the lock-on. Now we have, now it comes the issue that we can't really change targets. Okay. So we're going to add that on a later part because we are about half an hour in, and I think we've done too much already for this part. So that's it for now. Obviously, we still have a lot of things to do, and we need to bring back the roles at some point, and we're going to do that on the next part. So as always, you know what to do. Like, subscribe, and if you like to see more stuff like this, if you like to see more videos, more series, and pretty much everything else, then consider supporting my Patreon so we can keep making a lot more of these videos. I'll see you next time.